This is question 11 in exercise 4.3 in Project Maths 3A. Two ships, X and Y, left a harbour, O, at the same time. X travelled due north at 20 km per hour, while Y travelled in a direction north 60 degrees east. After 1 hour, Y was directly east of X. We've got to calculate, first, the distance travelled by Y, and second, the distance between the ships correct to the nearest kilometre. Okay, so we're going to need to draw a diagram to start off with for this. So we start off with our harbour, which we'll mark as O. Now X travelled due north, so it went straight up like that. So we got X just there. Whereas Y travelled north 60 degrees east. So it travelled off in this direction here, forming an angle of 60 degrees just there. And then you can see that they are okay, so Y is now directly east of X after an hour. And you see that their shape here, the lines of their travel have managed to form a right angle triangle with the right angle just there. So we're going to solve that right angle triangle to get the two distances we need. The first one we're looking for is the distance travelled by Y, which would be this line over here, which we will call D1. So we'll start off with that. So for part 1, we've got the distance X has travelled, and we've got to find the distance that Y has travelled. But the thing is, we haven't been given the distance X travelled. What we have been given is the speed at which it travelled and the length of time for which it did that. So if X was moving at 20 kilometers per hour for 1 hour, which means that the distance X has traveled is going to be 20 kilometers. So this value right here on the triangle is going to be 20. So we've got, in relation to our angle here, our adjacent side, and we're looking for the hypotenuse. So we can say that the cos of 60 is equal to, and it's going to be adjacent over hypotenuse, so 20 over D1. And now we need to just get to a point where we can get a value for D1. Well, we're not going to move our 20 over right away because that won't quite work with the way that we work with algebra. What we're going to do first is going to bring our D1 over. So we have divided by D1. We bring it across, it becomes multiplied by D1. So we get D1 cos 60 is equal to 20. And then from there we've got our multiply by cos 60. So we're going to bring that across. It's going to divide by cos 60. So we end up with D1 is equal to 20 divided by cos 60. We can stick that into our calculator. We get our value for D1. So D1 in this case is equal to 40 kilometers. So that is the distance travelled by Y. Now for part 2, we've got to find the distance between the ships correct to the nearest kilometre. But we don't need to use our answer for part 1 for this, although we could if we wanted, and we could use Pythagoras' theorem with 40 as our hypotenuse, 20 as our other side, and as the side we do know, and the distance between X and Y as the side we don't know. But we're not going to bother with that. We'll call the side we don't know over here D2. And we're going to use another trigonometric ratio. So we've still got 60, we've still got our adjacent side, we don't know our opposite. So we can say that the tan of 60 is equal to opposite over adjacent, which is D2 over 20. And then we're going to bring our 20 over. So instead of divide by 20 from the right, it becomes multiply by 20 on the left. So we have 20 tan 60 is equal to D2, which means that D2 is going to be equal to 34.641 ... We don't need to necessarily get the rest of them because the question specifically asked for a correct to the nearest kilometer. So that means that d2 is going to be approximately equal to 35 kilometers, like that. And that is that.